Hi everyone, welcome to our talk, How to Successfully Develop Software Products. I'm Olivier, this is my colleague Ali, and together we have about 18 years combined experience at the following audio companies. And so today we're really excited to have this talk with you because I think like many of you, there have been days at the office where everything seems like it's going well, right? Like you come into the office, you're productive, everything lines up, you communicate with your peers, everything goes well. And then for some reason, some other days, everything just like grinds down to a halt, like you're not able to communicate, you think it feels that you're achieving nothing, even though you're still working on the same projects and you haven't changed anything. And so in these times of doubt, usually we've been looking for advice. And the good thing is, as software developers, there's a lot of advice out there. There's a lot of conferences like this one, lots of books, lots of things to reference. And so this advice might look like this. So advice about how to organize large code bases in large organization. It might be advice about C++ technicalities and best practices. It might be about technical depth, and it looks very good when it's on slides like this with pretty colors and 4 quadrants. Or it might be development methodologies that promise to give you everything, like we have here: early risk mitigation, increased customer satisfaction, continuous improvement and learning, maximizing return on investment, effective collaboration and team management. I want all of this, right? I think we all want all of this. And what we found is that often you feel like you have a problem, you look for advice, you find something, and it seems always relevant. And so whatever you found last seems to be the most important thing. It seems to be the source of your problem. So if you look at technical debt, maybe you're like, oh yes, I have tech debt, maybe that's my problem. Or you look about development methodologies, and suddenly you're convinced you need to change your entire project management strategy because you're not using Agile, for example. But somehow you change something, it doesn't seem to cut it. It doesn't really help. And so why this talk? Really, it's to take a step back, breathe a little bit, and hopefully give you pointers to look at your next project from different angles. And the S here is critical. We want to look at projects from many different angles and try to understand how we work as software developers better. And so the title of this talk is How to Successfully Develop Software Products. And like many other talks, we won't have time to dive deep in a specific aspect of software product development, but we will reference a lot of other content which you can look at later after this talk to learn more. So we talk about success and we talk about products. Software, I think we can all agree what it means. So what is our goal in this? So we want to build something, that's the software we're building. Obviously, it needs to be working. I think we all agree about that. And it needs to be useful. If it's not useful to some customers, it's not a product, it's just a piece of code that does something. And so that's part of the success, finding customers, being useful. And also we want to enjoy the process of developing this software. For us, it's key. If we ship something, it works, it finds customer, it makes money, but we end up completely burned out at the end of the process. For us as software developers, I think we haven't succeeded because it's not sustainable in the long term. So some caveats. This is a lot of this is from our perspective working at L-Acoustics, which is a professional sound system manufacturer where we build loudspeaker, electronics, and software for the world's largest events. We have about 200 people working in product development, so from engineering, software, hardware, product management, industrialization department, technical information. We have high reliability needs because we work on these large events. And also because a lot of these systems, although we're not building airplanes, there's a lot of safety critical things when you're hanging 2 tons of speakers above people's head, which are powerful enough to destroy the hearing of someone. So we want to move fast-ish, let's say as fast as we can, but we definitely don't want to break anything. All right, so that being said, everything starts with an idea. And you will have loads of ideas, and you will be convinced they're good ideas, right? So maybe they're good ideas because they're very innovative and therefore unproven. So maybe you're not actually that sure that they're good ideas, and we'll come to that later. maybe they're so simple, I don't understand why no one did it before. And that also should raise some eyebrows when you have these kinds of ideas. Or actually, in a lot of cases, it will be similar to something that already exists, right? But better, or at least you think it's better. Better because it's integrated in your existing product, better because maybe it sounds better, it's easier to use, it's more powerful, flexible, whatever. Maybe it's cheaper, you name it. And so the first step is to sort your ideas to decide what to be working on next. And when doing this, a lot of people look at these kinds of charts, so cost and return, so to look at a return over investment ratio. But personally, I don't really like to look at it this way because it's a very financial way of looking at things. And at this stage, it's just an idea. It's still very blurry, undefined, so you don't really know how much it will cost and you don't really know how much revenue it could bring, right? You don't have a business model in mind, none of that. So I prefer to look at it in terms of effort and impact. And effort is more than just money spent, and impact is more than just money in, right? So, for example, the effort might include technological risks. It might include opportunity costs also, because it means maybe you're not working on something else that you could be doing. And the impact, maybe it could be expanding your customer base, which may not make you money in the first time immediately, but might lead to something better. It might be starting to master new technologies, which maybe for this idea, this specific idea, won't be that transformative, but could prove to be a stepping stone for later, right? And it's more about hierarchy and sorting rather than absolute numbers at this stage. And so on that graph, you have the low impact, high effort stuff. So like, don't even think about doing those. You have the high impact, low effort stuff, which you should have already done. So for this, like, just don't hesitate, go and do it. The low impact, low effort, which is like, man, like there's nothing inherently wrong with doing these things. This might be like small improvements that are not life-changing. They're not hard to implement. But they're not terribly exciting to do. And if you spend too much time here, like you won't stay motivated for very long. And then obviously there's the high impact, high effort stuff. And this is where innovation lies. This is what sets your company, your product apart. And this is also what is motivating as software engineers. This is where the hard stuff, right? This is where the hard stuff, the things that we enjoy working on aligns with the goals of your company. But you have to be careful with this, because at this stage, there are error bars, right? So your idea is still very blurry and undefined. So there are big error bars on your effort. It might be harder than you think. And there are also error bars on the impact. It might not actually be that interesting to that many customers. And it's very easy to get excited. And so before you know it, you end up here and you spent 2 years instead of 1 year, and you've got 100 customers instead of 10,000. And you're not happy. And so a lot of this talk will be about how to mitigate that risk and address that at the right stages in your project. But so let's say we're convinced that we should start working on this. So we're going to be building whatever this idea is. And so the first question to ask ourselves is, should you really build all of it yourself? And by that, I mean, should you make it or should you buy it? And so if you go the make route, obviously you have full control over what you're doing, but maybe this is something new for you. Maybe you don't have the competencies in-house. So for example, maybe you're moving from doing juice-based UIs to some web UI developments because you think it will be a faster way of developing your UIs, but you're not really that well versed into web development. So you may need to train people, maybe even hire some external people. So that will take time. So that, yeah. Time frame might be longer. And also, again, there's an opportunity cost, right? You have to ask yourselves, what is your company really good at? Where can you bring in the most value? And you shouldn't divert people who are great at some very specific things that are very important for your company to do mundane things that can be done very well by other people, right? So that's this opportunity cost. If you buy or license an existing solution from someone else, obviously you give up some control. You might become dependent on that third party, depending on how critical this building block is in your product. And it might be quicker, but also I think we've all seen that in the world. You get a quote from someone to do some amount of work, and they say, yeah, sure, I'll do it in 2 weeks for this amount of money. And before you know it, it takes 6 months. So you have to be careful when you choose your suppliers. two other important things on this topic. If you decide to make, so to build something new, not buying an existing solution, you might subcontract that if this is a skill you don't need for very long. And also buying sometimes is actually free, so don't forget to look at open source software. And regardless of whether it's open source or licensed commercial solution, be careful. You might start depending on some critical piece of code that maybe won't be maintained either by the original authors or maintainers if it's open source. In that case, you might pick it up yourself and it might be fine. If it's intellectual property from a third-party company, if they just decide to stop making this or they just go out of business, you might be in a much trickier situation. And so Dave, 2 years ago at ADC, made an entire talk going over some technical points on why you shouldn't build a DAW. So now that this part is out of the way, let's see how to go about things when we decided to make it ourselves. And so, as we said, we have risk here. So there's two kinds of risk, right? There's this impact risk, which is a product market fit, right? Are you building the right thing? And then there's this technical risk, this effort risk, which is, can you actually build it? Is it technically feasible? And if so, in what amount of time, right? So again, we don't want to end up here. And Ali will now talk to you about how to reduce those risks.
Okay, so yeah, we've decided to build something, but we want to understand what technical risks do we have, how do we mitigate them, how hard would it be to build them. So the obvious thing is to build a prototype, and then test it, but then importantly, throw that prototype away when you've answered the question. I think that's particularly important to point out in the software world, because unlike the hardware world where you might be building some electronics on a breadboard like that, it's very obvious to all stakeholders, anyone who sees that, that's probably not what the end product's going to look like. But in the software world, it's very easy to add maybe we already have a product and we want to add something new. We might test something out in the product. So you give it to someone, it might feel like it's finished, but underneath there's lots of technical risks that you haven't addressed. And before you know it, your marketing team has started marketing it before you've finished de-risking everything. So yeah, beware of in-product experiments. Let's take an example. You want to add some machine learning to audio processing to your product. What sort of things do we want to de-risk? So first of all, what can we find a suitable model architecture? Does it train well? Is the sound quality good enough? Can it run fast enough, reliably on the target hardware? And is the overall experience in the product good enough? And so in order to answer this thing, there's a few different tools. Obviously, like the first one, most machine learning research is done in Python. Is the sound quality good enough? There's obviously, again, you could do some offline processing in Python, send out some audio files, see whether people like the sound of it. Alternatively, you can maybe build a small demo in a VST plugin so people can use their own audio input to test things. Can it run fast enough on the target hardware? So you could once more, maybe you've narrowed it down to a few different models, but you haven't finished all the training. You can still take these models, use some random weights, try out different runtimes, see which works best on your target hardware. And finally, is the overall experience of the product good enough? You can perhaps take an early model. Doesn't need to be as good quality-wise, but you can then put it in, attach some UI elements to it, and get some people to try it out and see whether the overall experience is good enough. And I think if you break it up and use different tools, different prototypes to answer these questions separately, they could also be done in parallel by different people with different teams or different expertise. But again, be very clear with whoever you're giving this stuff to, all your stakeholders, be clear exactly why, what the purpose of each prototype is and what the limitations are. So that was de-risking the technical risks. What about the impact risks? Well, yes, you could do some user surveys, feedback, market intelligence, word of mouth, speaking to people. But you could also build proof of value prototypes, in contrast to the proof of concept prototypes we were just talking about. This might be something something you can give to customers and see, so you can ask them whether they would buy it and whether they find it useful. Again, it's very important to be careful about how you communicate this. Again, this is probably not, there might be some technical risks you haven't de-risked. So maybe don't let your customer use it on their big, the big show they're doing. It's highly important, but they might want to test it out during some pre-production or something like that. And yeah, you don't want to spend too much time necessarily building this, just in case there's some technical risks that make the whole thing non-viable. Another approach is to build a minimum viable product. Maybe you've kind of de-risked some of the high risk stuff, and you want to test whether it really brings value to the customer. So yeah, it's important to know it should be a product, so it should be bringing value to the customer. It's also important that it also needs to be viable, as that's in the name. But it should be as good a quality as you would expect your final product to be. It should look and feel like a real product, and should be have the quality that makes a customer excited about using it. But it still needs to be minimum, so that you don't put too much effort in before you know that it's going to be a viable product. So that's choosing the scope of what you put in is the very subjective, but that's very important to ask those hard questions. You don't you want to minimize the scope, but not so much that it is not valuable as it is to your customer. There was a talk from Roth last year all about MVPs and prototypes, and goes into a lot more detail than we've got time to today. So I'd highly recommend that talk. So now we've de-risked the big unknowns. You need to stop prototyping and start building and hopefully finishing something. And at this point, there's almost certainly going to be some kind of time pressure. So hand over to Olivier to talk about how to deal with delivering on time.
Thank you. So as Ali said, once you've proven that the idea is important, you've decided to commit your full company resources to this, there will be some form of time pressure. And so first question to answer is, why does it matter to be on time? And so in our case, it matters because product development doesn't stop at the software team. So for us, for example, we have a documentation team. We do also in-house training of our users. There might be some marketing campaigns that need to be ready for product launch, and maybe even the sales department might be waiting for you to be able to sell this thing. So when you start communicating deadline to all these people who have other projects to work on, who need to be organized, you need to stick to them as much as possible to make their life easier. It might also be because maybe you're working on a large cross-team project. So at Dell Acoustics, we have a lot of hardware and software combined projects where the hardware and software timelines need to align. Or it might be a full software project, which maybe has a cloud component, which is done by one team, and a desktop application component, which is done by another team. And same thing, like these two need to line up to be released at the same time. Also, we did this initial impact and effort assessment. If you're not on time, it means you're overspending. So it means you're not sticking to the initial effort you budgeted. And so your entire your entire point for starting this development might actually go out of the window, right? And also, we have other things to do after that. We all have busy roadmaps. As I said, we all have lots of ideas, and it's just never nice for projects to feel like they're dragging and somehow like the goalpost keeps moving and seemingly like without ever ending, right? So I would say there are two fundamental approaches to delivering projects on time. There is the what I would call like the specify, estimate, do method, which starts with a specification, or actually like the first level of specification is more like a wish list that might come from the first experiments you run. Then you will want to estimate the complexity of what you want to build as best you can. From that, you will try to derive a planning, and then you will try to stick to that plan. And so the problem with that is estimating complexity is is extremely hard because developers famously always underestimate how complex things are, and there might also be a lot of things that you just didn't even foresee that you completely forgot to estimate. And then sticking to the plan is also extremely hard because you keep discovering new things. You want to add, oh, it would be nice to have this, it would be nice to have that, and then the scope creeps, and it's very easy for projects to get like a third more work added slowly, gradually over time. But regardless, if you decide to go for this strategy, then you will need to have a way of delivering that plan, right? And for this, you have what I would call traditional methods, so waterfall development, V-model development. And then on the other side, you've got the agile methods with maybe Scrum, maybe Kanban. And people tend to look at these two things in a very binary way. But actually, I think what matters is your adaptability to changing requirements. And I think this is a fine continuum. If you go for a V-cycle, but on a fairly small component, and that V-cycle is not long, you still have an opportunity at the end of that V-cycle to change course. Likewise, I've seen a lot of teams do agile and they do sprints, but every sprint they don't ask themselves if they're still on track, if they're still delivering the right thing. And so they don't use the opportunity that they have to change course and steer the ship. And at that point, they would have been better off just going for a traditional development method like a V-cycle where you specify, build low-level components and then integrate, which usually, if you don't need to change course, will be quicker. Yes, so beware of what we would call the cargo cult agile. If you look online, you see a lot of people hating on agile methodologies, especially Scrum. And when you dig a little bit deeper, you see that they have sprints, they have tickets, they use a project management tool like Jira, they do planning poker and all these things. But all of this process brings zero value to the team. And so, yes, the key thing with Agile is you have to be transparent and you have to constantly check that you're building the right thing, right? These are the two things that you should be looking at. So again, yes, the risk comes from your inability to adapt to change in requirements and change in market conditions, right? So if you decide to go for these methods, regardless of the one, to avoid scope creep, it's very important that you have at all times an idea of how much work you've done and how much work is left to be done. So this is an example from one of our projects. So the gray line is the to-do, so it's measured in story points in that case, and the blue line is the done. And so you can see early on when we started working on the project, we started to have some scope creep. And thanks to this tool, we can see that we already have like plus 10, 15, 20% already added it just within 1 month. So quickly, we decided to outscope some of the nice to have features that we thought weren't critical for this release, right? So it's super important that you also have some buffer, that you have things that are not must for your release, right? And then we can see even after that, the scope continued to creep a little bit because we found some things that we considered were actually important for the initial release. So if we look a little bit more into detail, also an effect that you need to be aware of is, so this is the per sprint burn down. So each bar is a sprint. In this case, it's a 3-week sprint, and the green portion at the top is how many story points the team did. And you may assume that this should be constant over time because the team doesn't change. These tickets are supposed to be estimated by by the team. But often what we see is at the beginning, the velocity is quite high. And that's because the team starts, in this case, they started with easy things because the hard stuff wasn't specified enough, right? So they actually started with nice to have. And then they got into the meat of the project where the really hard stuff was. And you can see even by splitting into small tickets, estimating individual tickets, they still underestimated and their velocity went down. And then they got to the end of the projects where things become a little bit easier. And then suddenly velocity increases because they're putting the finishing touches and they overestimate how long a sequence of small, easy tasks tends to be. And so this is an effect we've seen many, many times. So be aware of that. And if you want to learn more, we reference this talk from Simon and Ross from last year, which goes into probabilistic forecasting and also the reasons of why not all projects are created equal in terms of complexity. And so in this talk, they talk about the Kinefin framework. I won't have time to go into detail here, but it's an extremely valuable tool to acknowledge that not all projects are created equal. And the most important part is this bit here. Different situations require different ways of navigation. And maybe that's the theme of this talk, right? Is, as you will see, there is no one solution which fits all needs, right? So that was for the first approach where we try to make a plan and we try to stick to that plan with all the risks. The other approach is what I would call like a time box method, where you define how much effort, how much time you're willing to spend on something, and then you start working and you see where you end up. So if we look again at this slide, we have uncertainty on both the impact and the effort. And here we just decide to remove the uncertainty on the effort because we say we will work this amount of time on this. So really it's how much you're willing to spend on an idea compared to how long it will take you to get to a specific goal. And so this is something that comes from a company called Basecamp, and they have this development process that they use in-house that they call Shape Up. And they talk about appetite. So I will read the quote. Appetite is completely different from an estimate. Estimates start with a design and end with a number. Appetite start with a number and end with a design. We use the appetite as a creative constraint on the design process. This principle called fixed time variable scope is a key to successfully defining and shipping projects, right? So essentially what we're saying is within quality, scope, and on time, you have to pick two. I think most of us will agree no one likes shipping bad quality work. So the question is, do you pick on time, on scope? And at Basecamp, with their Shape Up process, they've decided to be on time rather than to stick to a specific scope. So just be careful with that. For this to work, the time box needs to be short enough so that the deadline is looming in everyone's head, because you're essentially replacing a complex planning and fine-grained task estimation by a mental model of how much time you have left and what you can do in that time. And this only works if this time box is short enough, right? So as I said, just like we're bad at estimating how long it will take us to do hard things, if I ask you how much things you can do in 1 year, you're extremely bad at this. But if I ask you what you can do this week, suddenly you're a lot more likely to have a good answer, right? And obviously it needs to be long enough to build something meaningful. So in this Shape Up process, they recommend 6 weeks followed by a 2-week countdown. So bearing in mind that this is a software as a service company building web products, so maybe not all of this applies to audio development, but I thought that was interesting to mention here. And so now is also the good time to ask, like, how much should you actually design before you start implementing? And Ali will talk to you more about this.
Thank you. So yes, when you're designing ahead of time before the developers start working on writing the code, there's a fine balance to be made. You don't want to start with designs too early, because you'll get the wrong feedback if you start doing super detailed designs. You'll be asked, people will be debating whether the button should be on the left, whether it should be blue or red, but no one's actually asked the question, should the button be there in the first place? So again, from this Shape Up methodology, They talk about fat marker sketches, which similar to a wireframe, but I quite like the analogy of using a fat marker because it's you can't do detailed drawings with a fat marker, and you'll be focusing on the higher level, de-risking the high level concepts, finding the edge cases, rather than getting stuck on the low level implementation details. There's also a balance to be found between asking your designers, giving your designers enough time to research the problem, maybe conduct some testing, but you also want, and you want to avoid too much context switching between asking developers for feedback on the design that they might not implement for a few months, and what they're working on now. So yeah, speaking of developers and designers, let's talk about, let's talk about the people on the team.
Yes.
I'll hand back over to Olivier.
So we haven't talked about teams, and I think, I went backwards. So usually projects, they start off quite small, so you have one team, and in there, so if we're talking about audio products, you'll probably have some software developers, some people who do UX, UI, maybe some signal processing, and maybe some product management. At the beginning, some of these roles might actually be handled by a single person, right? So you might have someone doing UX, UI, and product management, for example, or DSP and product management if they're an expert in the field. And so at the beginning, this is what I call easy mode, right? So you're in a team of 3-4 people. Everyone knows what they're doing. It's easy to communicate. It feels like everything is going fast. You're happy to come into the office. And you don't need to really think about project management, right? Like all of the things we talked about before, like you don't even need any of that. But then suddenly, like your product is successful, great. And so you start putting more features on the roadmap and you start putting more ambitious features as well. And suddenly you realize that now you have like a 2-year backlog of stuff you want to implement. So you're like, okay, maybe we should increase the team size to deliver this a little bit quicker. So you increase the team size. Maybe you have 4 or 5 software developers. Maybe you have a full-time UX UI person, a full-time product owner if you're doing Scrum. And then suddenly, like it looks like everything is slow and grinds to a halt. You don't know how to communicate anymore. You see like things like duplicated work or unspecified work. There's a lot of back and forth between the developers and the product managers. The designers design things that are unimplementable. And so you come to the realization that teams have a maximum size and somehow your team is too big. And so you need to split your team. And so you will need to split according to areas of expertise. So the way you split, there could be an entire talk about this. You could split by area of technical expertise. You could split front-end, back-end, audio processing, UI development, or maybe more by feature sets in your product, right? So this is completely up to you. There are other material you can reference on this. But regardless, at the beginning, when you have multiple teams working on something, there will be some form of tight collaboration at the beginning of a project because you will all be interdependent for many components in your product, right? And so this works if teams are dedicated to a specific project, so they are just starting to spread apart. And then you get to a point where you have more like a limited collaboration. So for example, if you decided to have a separate DSP team which specifies the audio algorithm you're implementing, once you have a first release out, maybe you'll get some feedback from the customer saying they found some edge case or they want a new feature. You hand this over to your product management. Your product management talks to your DSP developers. You give them some time to come up with a solution. Then they give you a specification. You implement it. You might have a few questions about that specification. Maybe you find some holes in that spec, so there's this limited collaboration, but then you implement it and you're happy with it. And then finally, there is the what we would call teams providing X as a service. So this is very common in very large software organizations where you have a platform team building an API. They have their own roadmap. They build it, and that's what they build. And then if you want to build a product on top of that, cool, you can do it. If an API is missing, you have to somehow lobby for them to add it to their roadmap and add it. But your goals are now separate and not common, right? And so if you want to learn more about this is a fantastic resource, the Team Topologies book and website, which formalizes all of these concepts and also the way these teams interact at different times. And I also want to leave you with 2 quotes from Eugene Sergey from a Lead Dev conference this year. So your organization is a living product. Design it intentionally, evolve it continuously. And instead of letting your organization drive your system design, intentionally design your organization to mirror the product you want to build. And so this is very important because if you have, let's say, a separate UX UI team and some product teams, your UX to UI team will have a hard time driving the product vision, and they might end up building something that's easy for them to do, like they might build a great design system that then no one ends up adopting because it's too hard for other teams to adopt, right? The other thing that you need to acknowledge is that this is a big change, working from a small team which has a lot of different people with different capabilities that all work together to this more separate approach, and different people work best in different environments, right? So there's this metaphor which I like a lot, the pioneers versus the settlers and the town planners. People who like working in doing this kind of town planning work are not the people you send at the beginning of a project when you're still like chopping trees in the jungle, right? And so be aware of that. Make sure that your people are correctly placed at the right stages of the right projects. Otherwise, they will end up being demotivated. And so finally, about team organization, I wanted to give you an example of how we decided to structure it in the last 2 years at Acoustics. So we've decided to split into research, technology and platform, and product development. So in these 3 pillars, we have multiple teams with different expertise. And these teams communicate in all sorts of ways, right? So for example, a new audio algorithm might be developed and tested by a research team, and if it's simple to implement, it might go straight into a product team. If we decide that it's a complex development, we might hand this over to a technology team, which will build a reusable library that we could then reuse in multiple products if we think it's worth the investment. It might be the other way around. It might go into the product first and then be handed over to a technology team because we want to reuse it somewhere else. And also, these technology teams serve as enablers for the research teams, for example, by building new features in our products that our end users don't necessarily need, but that make the life of our research teams easier on the field, right? So to make sure they have smooth workflows. So researchers are not usually expert at large-scale software architecture design. And so their role is really to remove the friction between their research to help them get to the results they want to get to as quickly as possible, right? And so we have this for software, and we do the same for loudspeaker and electronics. And the last thing we want to address is, just as your organization grows over time to support a more larger and more mature product, so will your code base, and with that comes the dreaded technical debt that Ali will talk about.
Yes, so as your product grows, you'll undoubtedly acquire some technical debt. So first of all, let's address exactly what it is. So I like this quote. It's a mismatch between the design you have and the design you need. It could be some untested code that needs heavy refactoring before you implement it, some architectural limitations, maybe some heavy coupling going on. That means you can't change one area without having to change another. It could be a knowledge or skill gap in your team. Maybe you need to use a new UI framework and no one knows how to use it. Or it could be something that's been deprecated and you need to replace. So I want to talk a bit this stage about how the Elisa product that me and Olivier work on, how that evolved over the last decade. So it started off back in 2014. There was one in-house researcher and the founder wanted to start. They wanted to do spatial audio for live sound. It was not something that was kind of done on a large scale before, but they had an idea. They had the expertise in-house to build something build the core audio engine in something like Max MSP. But then they also subcontracted a couple of developers to build a kind of the UI control software. And so they were able to put together an MVP essentially, and that allowed them to start testing the algorithms that they wanted to use, check they had the right market fit, and they were able to put something together that was good quality, however had limitations in terms of had various technical limitations which were preventing them from kind of scaling up. So the next step was to hire some C++ developers. Well, once they realized they had a market fit, they basically rebuilt the audio engine in C++, so they had a lot more control, a lot more flexibility, were able to scale up the product. And then at some point, I forgot to mention that the first version was based on Windows 8 embedded on some off-the-shelf hardware. But at some point, again, they came across limitations on the Windows 8 operating system. So they moved to a Linux real-time operating system, and finally introduced some custom hardware once it started to gain traction and was starting to be used on big tours. Suddenly the hardware that they initially chose was not suitable enough, so they could, with the custom hardware, they could add some redundant PSUs and touring grade connectors. One thing I wanted to point out is, well, for example, if you ask ChatGPT what is technical debt, it says it's the implied cost of choosing an easier, faster solution now instead of a better, more sustainable one. And personally, when I read that, it kind of sounds like it's suggesting that the solution to avoiding technical debt is never choose the easy, faster solution, always think about the long-term one. But I think hopefully the example of what I just talked about suggests that actually that's not necessarily the right approach, and often choosing the short-term solution is the better one, because it allows you to grow quicker. And just like you can't grow a business without money, i.e. financial debt, it's also the same that you can't grow your code base, grow your product without taking on some technical debt. Or to put it another way, to quote this talk from the Lead Dev conference last year, tech debt is a natural product of innovation. You will always have some of it. So the key is not to necessarily avoid it at all costs, but it's the key to growing sustainably is to manage the debt, not avoid it. Things to be aware of is how much debt you have, how much interest you're paying, and when it's preventing you from taking the next step. So there's no need to, I'm sure we've all in our code bases have that one class which no one really understands, but it kind of seems to work. So there's no need to fix that. I know we need to pay off that low interest loan straight away. But once you want to start growing, adding features, maybe there's some area of the code base which is slowing you down. So that's when you start to pay interest, and that's when it's important to address technical debt. So that's kind of coming towards the end of what we got time for today. I hope we wanted to just talk about how there's lots of different. There's no kind of ideal methodology that will instantly take you to success, and there's every project's different. So I wanted to leave you with this quote from this Cynefin framework that Olivier mentioned earlier, and it says, "When you believe all is simple, everything is ordered, past success makes you vulnerable to failure. Oh, I can't quote. Before you know it, the chaotic domain grabs you by the throat and drags you into a crisis." Thank you very much.
Thank you.